And welcome back. As we go ahead and continue looking at debugging, today we're going to take a look at some general debugging techniques and apply that to some example code for us to pick apart. So the first thing we look at, of course, is fixing issues related to loops. Now, we've already done this with trace statements to help debug our code, but the big thing to kind of keep in mind is that trace statements can be both time-consuming and, of course, sometimes difficult. Rather than, of course, assuming that the bug is occurring in one place, we kind of examine our program holistically. We want to look at the whole thing to kind of identify any potential issues or errors. A good approach, therefore, is to look at segments of code that may have the underlying error with them. For example, if the program gives incorrect input values, you may need to test the logic behind your algorithm. So let's actually look at the steps that we need to start looking at how to troubleshoot this. So the first thing, of course, we want to determine the precise cause and location of a bug. That's the first step towards fixing any kind of error. And the way we can do this, we can start testing different inputs and outputs, such as using a positive value versus a negative value, to try and help localize the error. We can also use trace statements. Again, we can use them in moderation here to determine the value variable at a given point, such as before or during a loop. Again, you don't want to use trace statements everywhere because it could get very unwieldy, but we want to maybe use these if we want to isolate something down. Then focus on the code that we have recently made changes to, or if the code has produced kind of errors before. One technique, of course, is to block out a section of code. We can actually just comment it right out, so we can focus on a section of code. If we still get an error, then of course the bug is not within that commented code, so it's kind of a nice way. It makes it easy for us to examine large chunks of code at a time. We'll see this later on when we look at an example in Eclipse. So, what are some common errors to check for? Well, the first thing that we do is say, all right, well, let's look to see if we have things like an equals equals or not equals comparison statements, because that's a lot of times where an error might have because you're looking for a specific thing. All right, or maybe you have a semicolon that's terminating a loop prematurely. Maybe you have an off by one error. These are all things, again, to look out for. Looking for Boolean comparison statements that may inadvertently cause unreachable code. It's very easy, of course, to become frustrated when you're debugging and simply start guessing. Okay, what if I do this? What if this? Granted, if you start guessing, you can always undo. But just be careful because, if you do too much, then you could end up creating a bigger problem than what you set out to solve. And while this approach with using these common errors and trace statements, stuff like that, works for simple programs, it will prove more difficult or impossible to work with larger, more complex code. So it's imperative that we kind of have that fundamental understanding how one small change can impact our entire program. That's why we want to take that viewpoint of looking at the entire program. Even though we might look at segments, we want to understand that how everything kind of works together. So let's actually look at debugging some code now. If we look at this code here that needs to be debugged, we can see it's a very simple program. We have a string, we have a char, we have a scanner class, and inside we say, hey, we're going to enter option A or B, and we're getting input from the user to determine that, and you can see it's inside of a do while loop. Okay, cool. A pretty simple program here. It doesn't look like anything too complex, but obviously there might be some things that we need to address. So let's look at that first step. When we look at that code there, if we try to run it as is, we're going to get a syntax error when the code compiles. The line C equals substring of 01 is going to give an error. It's going to say incompatible types, found in the Java language for string class, and it's requiring a char. This is because substring is returning a value as a string when we want to store the value C, which is in a char. This, of course, is just a relatively easy fix for us to do. Simply say the substring to the char at method, and that, of course, returns a character for us rather than necessarily pulling in the whole value for us. Now, this, of course, again, this specific line of code, if we look at the C equals s.char at 0, is getting us the character that is in position 0. Now, if we go ahead and apply this to our code and we can update it, you can see how our code has changed a little bit. Now, again, it's a very quick, easy fix. We were able to say, oh, well, this is supposed to be a character type. It was a string type. So we've addressed that using the char at method to go ahead and update that. But, of course, there are still some errors with this program. If we go a little bit further in the program and we still try to run it, all right, we're going to be able to do things like input values now, right? Because we got the correct types. However, the code is not actually going to terminate its loop if you enter A or B. we have an infinite loop. All right, it's never going to exit out. And we could apply trace statements to test that code, figure out why is it not exiting that loop. Well, if you include the trace statements and output the value of s, you'll find that the output is not converting that text to lowercase because it's looking specifically for lowercase values. And again, this is another relatively easy fix. We can have the code s.to lowercase in here, but if you look at it, it doesn't actually store the value, because if I just say s.to lowercase, that takes that value, makes it lowercase, but it doesn't update the actual variable. So we have to say s equals s.to lowercase. So if we look at this again in our code with it being updated, you can see now we have s equals s.to lowercase in here instead of just the s.to lowercase that we had previously. Now this is a lot closer to what we want to do. However, there is still one small flaw with our program. So if we look at the program now and we say, hey, we want to take care of this. Well, we still have the infinite loop. We took care of that one piece of it that was causing it, but it doesn't actually exit the loop. That's because the conditions for exiting that loop are met. Now, of course, we could add break statements in here to force it out of that loop. However, this is a kind of a quick fix. All right? It doesn't necessarily properly solve the underlying issue within our code. Breaks will only treat this as kind of a solution without necessarily solving the underlying problem. So we're going to instead use a Boolean to test to see if C, which is of course the character we're getting, is equal to the character A or the character B. If it does equal those, then we can change the Boolean value from either true or false and force the loop to exit. Now, because we are a Boolean, here we are also going to have to change the conditions of our while loop because before it wasn't set up that way. So when we look at our fixed code here, you'll see we of course now have in here a Boolean, which is by default set to true, so we're explicitly making this true so we know that it's going to run properly. And in our dual while loop, you can see now it says invalid key down here, so we're setting that to true. And so it's going to run through this loop until it is set to false. So we said if C is equal to A or C is equal to B, so if, else if. Now of course we could do this in a single statement, we could have a or in here. Either way though, we could have two different things that are setting this to false, and when it sets to false, of course it will meet the condition for this loop to exit because it's going to do this while check. It's going to find it's false, which means it'll then exit out of that loop. And so let's go ahead and look at some debugging techniques applied to an actual program now. And so here in Eclipse, you can see I have a quick program that I've made up, and I've purposely left some errors in here. And so I want us to look at this because I want us to look and say, what are the things that we can do to actually solve this, right? So first thing I do is I look to see, okay, are there any syntax errors? And syntax errors are easy ones to find because we have these red squiggle lines, right? So we can look and see, oh, these things need to be fixed. So I'm going to start always at the top of my program because if you start looking around in different places, you can actually inadvertently sometimes make different problems that you didn't set out to fix. So we always start at the top here. And it says it's right here on line 6. It says scanner KB equals new scanner system in. If I look at this, I realize, oh, I forgot something here. All right, and you can see there's a little red squiggle here that tells me I forgot to put something here. What did I forget? Well, I forgot a semicolon. And you see when I put it in there, that error has gone away. Perfect. Now I'm going to go ahead and move to this next piece here. Now before I go ahead and finish fixing everything, I'm just going to go ahead and just do a block comment here, just so I can show you how this works. So I'm going to go ahead and start a comment with a /*, and then I'm going to go right after this and do */. And now that that's in there, you can see how this whole block of code is commented out, which allows me to focus on this first section here without worrying about what's going on down here. So I'm just going to go ahead and save this real quick, so that way I don't have to worry about, again, what's going on here. And I can focus right here on where this other area is. So it says, type mismatch cannot convert from string to int. And if I look at this, it's because I put in here, I have an int, but what am I getting? I'm getting a next line. Well, that tells me that I probably put the wrong method here. So I'm going to go take out the next line and change it to what it should be, which in this case should be a next int. And you can see that the error has been resolved. Perfect. Let's go ahead then and take out this block comment now, because now I can focus on this comment down here. Now I notice I have some more errors here, and I can of course look at this statement right here. The if statement looks like it's pretty happy. I don't really see too much going on with it. So let's look at my else here. And I'm not sure what's quite going on yet with this, but if I look at the system on a print line, I can see there's a couple things. Oh, I forgot my semicolon, that's there. But you can see I also forgot to put the quotations around my string which should of course resolve that one. Now this one is saying I still have an error here. Why is there an error here? Yeah, I have an if else. It looks like it's working. So what I'm going to do is I'm actually just going to go ahead and block comment out just the else statement this time. So that way I can focus on just the if statement and see if there's any issues there. Because it's very likely that this else statement could be stemming from something I did up here. So I'm going to look at the if statement here. And I have an if statement. And I have an if blah, 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 blah. That looks good. But if you look, I have a curly bracket here. Where's that one going? Oh, it's going to this while loop. But wait a minute. If it's going to this while loop, what's the bracket for the if statement? If you look, I have a semicolon out here. And if I were to run this, it could potentially work. However, the reason why we aren't necessarily hitting this else statement is because if I take this out here again, I could also just go right here to where these curly brackets are and look to see, Eclipse is very nice to show me where they're paired, and I can see I am missing another curly bracket here. So I'm going to go ahead and put this curly bracket here. However, you can see that this one jumps up here to show that's paired with the main method, which means that this bracket actually is missing its partner. So if I look at my if statement here, what do I have here with my if statement? I have a semicolon. And so if I were to, of course, I'm just going to, for example, just right now, just take this out just for a second. Take this out, you can see it compiles. Because you can technically do an if statement with a semicolon if it's a single line of code. However, I generally advise away from doing that because it does make things a little bit more complicated. So we're going to say that this is an issue here because again we have multiple lines of code that we're assuming should be part of this if statement. So I'm just going to go ahead and change that to a curly bracket. And again, this is one of the reasons why I say whenever you're dealing with if statements or you're dealing with loops, even though yes you can do a single line with a semicolon, I always advise to use curly brackets because it's going to make your life a lot easier because then you're not going to run into issues such as this. Alright, so now we've solved that. Let's go ahead and run our program to see if this works the way we expect it to. And so it says please enter number. So I'm going to go ahead and let's enter in 50. Alright, and you notice we have a loop going infinitely. Alright, cool. So it's saying 50, 50, 50, 50. Awesome. So if we look, we're entering in a positive value. We're displaying all those numbers here. But we never actually have anything other than this being displayed here. So let's look here. So it's printing out num1, which is great. That's what we want to do. But if it's going on forever, that means that this loop most likely does not have a counter. Now I could of course put print line statements here, but I can recognize very quickly that this is just missing an incrementer. So I'm just going to go ahead and add in something to increment it. Since we're just printing out num1, I just need to increase the value of num1. So I'm just going to add a num1 plus plus. And so now if I go ahead and run this program, let's go ahead and put 50 in again, you can see that it has now run this code and it's going from 50 all the way to 99. Wait a minute here. If you look, it says displaying all the values from the number and to 100. Should say to 100 there. All right, if the value is smaller than 100. So that means that my conditional here isn't off by one error. So in this Boolean expression, I'm just going to change that to a less than or equals to. Rerun my program. Let's put 50 in again. And you can see now I get 100. That looks awesome. And let's just test out to make sure our else statement is working, because whenever we have a if statement like this and there's an else condition, try to trigger the else condition. So let's just put in like negative 50 and we get you entered a negative value. And just like that, we fixed everything that it is to be debugged with this program. You can see there was quite a lot that we had to do there, but we now have our program up and working.